Hello, my friends, and welcome again to this quick revision in your favorite subject, chemistry. This is the 10th class, and in this class, we are going to carry on talking about the atomic and relative atomic mass. Before I start answering the questions of this class, allow me to revise for you the main and important points we have talked about so far. Actually, my friends, in the last class, we have talked about the atomic mass, and we said that because atoms are different from one another in terms of number of protons and electrons and neutrons, we should put a unit scale to calculate their masses. And we said that if we want to calculate the mass of any atom, we should start first establishing a unit measurement. And then we said that our unit measurement is going to be 1 AMU. Again, A stands for atom mass unit. And we said that if we want to calculate the atomic mass of any element in the world, we depend on the mass of the protons and neutrons, and we should exclude the electrons from our calculations, because 1 AMU is equal to the mass of one proton equals to the mass of one neutron equals to the mass of 1,837 electrons. And because of the mass of electron is very, very small, we said that it's allowed for us to exclude it from our calculations. So, depending on this information, we can say that the atomic mass of copper is 46 AMU, and the atomic mass of iron is 58 AMU, because here we depend on the atomic or the mass number, and which means the number of protons and neutrons, and with excluding the number of the mass of electrons. And here the goal is 196 AMU. Now, my friends, the question of our class today, or the questions of our class today, emerged because of having a problem which is called isotopes. After the discovery of isotopes, we had this problem. The question is, as we all know, those are all atoms of the same element, which is iron. Each one of them has 26 protons inside its nucleus, so they are all belong to the same element. Now, if I want to talk about the mass of iron in general, which one shall I use? Shall I use 56, 57, or 58? To solve this problem, we have talked about something called relative atomic mass. So what is the relative atomic mass? The relative atomic mass is the average of the masses of those isotopes. In order to calculate the relative atomic mass, we should answer this question: what is the abundance of an isotope? Actually, the abundance of isotope inside the element is the percentage of this isotope inside this element. For example, if we take iron here and its isotopes, you can easily say that those isotopes are not existence inside the element with the same number of atoms or the same percentages. Maybe, for example, this one has more number of atoms than this one, and this one has less number of atoms inside the element. So the abundance of an isotope is the percentage of this isotope inside the element. Now, as we know how to calculate the relative atomic mass, of course, we're going to depend on the same unit of measurement, which is AMU. One proton is nearly equal to one neutron, which is equal to 1 AMU. Now, my friends, how to calculate the relative atomic mass? Generally, if we want to calculate the relative atomic mass of an element which has many isotopes, we use this equation. Relative atomic mass equals, this is a fraction, numerator and denominator. In this numerator, we can see that we have parentheses. Each parenthesis is going to be the multiplication of the atomic mass of isotope 1 by its abundance or its percentage. Then we have the atomic mass of isotope 2 multiplied with its abundance or its percentage. Then we have the atomic mass of isotope 3 multiplied with its abundance, and so on. Then at the end, we divide them into on 100. Now, my friends, we have here 192, and its abundance is 20. We have 193, 30. We have 5% for this one, 5% for the isotope 195, and 15 for the isotope 197, and 20 for the isotope 199. So the answer is going to be 190, I remember 94.8 AMU. Now, my friends, let's answer a question that was given for my students in the British syllabuses. The question is, calculate the relative atomic mass of those isotopes. First of all, we have to notice that the atomic number of those isotopes wasn't given. The reason is that generally we don't want it or we don't need it at all. So if you were asked to calculate the relative atomic mass and you were given all of the isotopes without their atomic numbers or their number of protons, don't get panicked and get relaxed and go through only the atomic masses and their percentages or their abundances for every isotope. Now we're going to apply the same rule here. We have 85, 68.077. We have 60 multiply 26, 33. We have 61 multiply 1.140, and we have 62 multiply 3.634, and we have 64 multiply 0.6. That's enough, and we have to divide them on 100, and that's it. That's it for today, my friends. I hope you enjoyed my class, which was a little bit confusing, so that if you want to understand more, please try to replay this video again, and don't forget to play some Kahoots, which are related to the atomic and relative atomic mass. Before I say goodbye to you, I will give you some exercises as homework, which were taken basically from official IG and AS exams. Thank you so much again, and see you next time. Please try to do the homework, and we will answer it together in the next class.